Hey class, I understand problem 39 from chapter 11 has been giving some of you guys a little bit of a challenge. So I wanted to go ahead and talk about it a little bit to help give you some pointers, especially in just trying to envision what's going on. So basically, what we have going on here is that there's this brake pedal that you can see over here. And what happens is you can see that our force F is being exerted on the brake pedal on this outer edge, a distance in this case of 0.15 meters away, these two distances added together, away from the axis where it can rotate. All right, and what's occurring as a result of that is then that's generating a force pushing down on this master cylinder, this piston. So let's go ahead, I'll pick red for that. And there's a force exerting down here, okay, which I'll call that the force on the piston. And as a result, that compresses the fluid, which then goes ahead to generate a force from these plungers on these brake pads on the wheel, inward in this direction. And so if we call that maybe the force of the brakes, then what we can see, that's a confined system with a fluid inside of it. So by Pascal's principle, we can see that the force of the force P here pushing down over the area of that plunger or piston. I'm going to erase that because it looks ugly. Okay, so force P, the force of that piston over the area, would be equal to the force of the brake over its area. Okay, so because we're asked, just so everyone's aware, we're asked to figure out what that force B is. That's really what the problem's telling us to find. So if we do the algebra, we can see, oh yeah, look, sure enough, FB is just going to be equal to AB multiplied by FP over AP. So some of you, I think, said, oh, look, well, F must just be 9.05 newtons, bada bing, bada boom, box worthy, and you got the red box of doom, right? Because that's not the correct answer. That's not the force. That is the force being exerted out on the edge. So I'm going to kind of redraw my brake pedal a little bit larger. So let's say this is the brake pedal. Here's our axis. All right, and so the force being exerted, the force F that's given to us, is here. F at a distance, I'm going to call this L1 away from the axis. And now what's happening is there is a force from the piston, a reactionary force, equal and opposite reactionary force, pushing up this way as a result of the downward FP force. So this we can also call F of the piston. Once again, I got sloppy, so I erased it. So this here is also FP. And we can observe that it's acting a distance L2 away. So in this case, we can see, just so everyone's clear, L1 is 0.15 meters, and L2 is 0.05 meters. So this axis, or this pedal, I should say, here, this guy is going to be in torque equilibrium since it's not actually moving. So we can do some of the torques for that. So if we went ahead to set that up, sum of the torque for our pedal is going to be equal to 0. We have a positive torque from F multiplied by L1, and we have a negative torque from FP multiplied by L2, and that's still equal to 0. So what we can do then is we can actually solve for FP in terms of our original force. Oh, that's interesting. Sorry, I thought my words were going to move up there. There we go. Okay. So if I just slide this up just a little bit, what we see is we can solve this for FP. Doing the algebra, we'd find FP is equal to F times L1 over L2. And then we can take this FP here, plug it in, boom, and then determine what B is. FB, the force of the brake, to get a box-worthy answer. So I hope that helps clarify. I think a lot of people are having a hard time visualizing what's actually going on with this pedal. But it's, again, a rigid body. We can treat it and do some of the forces or some of the torques acting on it. In this case, since we don't know what forces are going on at the axis here, it's best to just do some of the torques. So, hope that helps. Let me know if you have any other questions. Have a good night.